So in this class, guys, I want you to understand the basics. I'm not going to duel much. I want you to just understand the basics because we are going to use them in the next class or the next part that you're going to have. It is going to be now an application to what what I'm going to explain in this class that we are having, which is the derivative of a function at a point, at a point. That's a single point that you're referring to, a single point where you're given x and y, only a single point. All right, let us go back. Let us go back. The first class that I talked about was actually based on the average gradient, where I said in this case you are going to need two points in order for you to determine the gradient. That gradient that we're determining, guys, can be actually calculated not from 2 points, but from a single point, now referred as a derivative, which is the derivative of a function. When working with a derivative, you work with a point on the graph or on the fact, a single point. If this is the point, you work with that point. At this point, you determine the at that point, you determine the gradient at this point. That is at a single point separately. So this derivative that we are going to work with, it allows us to find the rate of change of one variable with respect to another variable. It's going to allow us to do that. It is going to allow us to find the gradient of a tangent to a non-linear function. It can be quadratic, it can be a cubic. So I'm going to explain about that later on, but let me just indicate what I just said here. So we said this derivative of a function at a point allows us to, all right, one allows us to, sorry, allows us to find, all right, what is it that we're going to find? The rate of change. The first thing is going to be the rate of change, all right, of one variable to another, like with respect to another variable, with respect to another variable. And also, it is going to help us to find the gradient, to find the what? The gradient, which is simply the slope. Gradient is simply the slope of a tangent, the gradient of a tangent. A tangent which is on a curve that is can you say to, yeah, the tangent to, yes, to a function, in our case, a non-linear function, a non-linear function. Why a non-linear function? Remember, guys, we are talking about what here? Gradient. Gradient. Remember, we're talking about gradient. So the gradient of a linear function can be determined easily, guys. 3x plus 4, you can just, okay, this is our gradient. What? The coefficient of x, y is equal to mx plus c. Remember, the coefficient of x, here m is your gradient. So m is equal to 3. But for a non-linear, you cannot tell, guys, y is equal to 5x squared minus 4. What is the gradient? And it is not just the gradient of the graph, it is at a certain point. We are talking about at a certain what? At a certain point. So whenever you're to deal with these, understand the basics, guys. These are the basics that you'll be dealing with. So it must be one to another. All right. So we're going to dwell into that later on. So what is this derivative that we are talking about? What is this that we are going to be talking about later on? The derivative. To find the derivative of a function simply means to differentiate. To differentiate. So don't worry, guys. I'm understanding you guys when I differentiate. What is it, guys? You're telling us about derivative. Now you're talking about differentiate. Complicated. No, it's not even complicated. It's not even complicated. It is just a way that you're going to use to find these, and that is going to be given in different ways. Whenever we're talking about that differentiation, it is to find the gradient, it is to find the rate of change, and there are ways that we're going to talk about later on, the first principles, the general rule, and also we are going to apply it in the cubic function properties, sketching of the cubic function, this and that. But for now, I just want you to know the basics and what you're going to face along the way. All right. So understanding this is where, or this is the application of our derivative. Then I want you also to understand the notation or for derivative, all right? The notation that you're going to use for any derivative. You'll be given, find the derivative of this. You are given f of x is equal to this, y is equal to this. Then you are asked to find the derivative, all right? So the notation that you're going to use will be the first derivative with respect to x. The first derivative f prime x. That is the first derivative f prime x. Or y bar like this. It is also the first derivative. You are given y is equal to, you can simply use y bar for a what? For a derivative of that function. Or you can use dy dx, y written in terms of x when y is in terms of what? In terms of x. It's gonna be f prime x, y bar like this, dy dx. These are notations representing what? A derivative of a certain function, or you can have this written as d of f of x. It's gonna be dx actually here, dx of f of x. Whenever you see this, the question is like, find this, or determine this. Know that they're actually asking you to determine what? The derivative of a function. Given that y is equal to 2x minus 4, then the question is find dy dx, It is the derivative. From this y is equal, find y bar like this. They are simply asking you to find the derivative f prime x, the derivative again. You are given d of x and you are given inside 4x minus 7. The question is just simplify or evaluate. Then you're asking yourself, what is it that I'm supposed to evaluate here? It is the derivative of this with respect to x. The derivative with respect to, like we said, the rate of change of one variable with respect to another one variable. So x, that is with respect to x. So we are going to apply this later on. For now, I want you to know the notation of the derivative and also the definition of a derivative. Mathematically, the definition mathematically. All right, the definition the definition of a what? Of a derivative. Of a derivative. Mathematically, we are saying if we are given the derivative, all right, let's say we're given a function. Let me write it down. The derivative, all right, sorry for that. The derivative of a function, the derivative of a function y is equal to f of x is defined as what? Mathematically, it is a limit that you are given. So that derivative will be taken as f prime x, which is equal to the limit as h approaches to 0 of, all right, f of x plus h minus f of x, everything over h. All right, so you might be wondering, what is this now? Do not worry. The formula sheet uh, is going to help us at the end of the day in your final examination. This formula is there in your formula sheet. It represents a definition of a derivative, which is our first principles. So we are going to dual match into that in our next class. We are going to be working with this formula, which is applied under what? Under first principles. So according to your syllabus, you must know this because you're going to have it as our next class. You must be able to find the derivatives of the first principles from a quadratic function, something of this nature, a cubic function of this nature. It can be a linear function. It can be just y is equal to c, a constant, y is equal to 3, y is equal to 5. It can be y is equal to a over x, something like this. Revise each and every one of these as per your syllabus, all right? As per your annual teaching plan, you must know each part. They can ask us anyone in our exam. This is a cubic, sorry, to the exponent of 3. They can ask any one of these for you to differentiate it from first principles. So you must know each one of these, how to differentiate from first principles before you look into the general rule of our differentiation or our derivatives. But for now, that is it. So you must know how to apply what? First principles. That will be our next class. First principles and how to use the general rule. This is the whole part of your derivatives. So like I said, expect these as we are moving on. This was just a class to notify you guys on what you must expect later on as we are moving on together. But for now, that is it till we meet again.